So there we go. So good morning for those who are joining us, and we hope to see some more pop on here shortly. My name is Lynn April. I am the director of the Center on Education for Economic Development at CESA 8 in Gillett, Wisconsin, and we are sponsoring these virtual job spotlights through the month of October. We've been concentrating on manufacturing because October is Manufacturing Month. So along with CESA 8 and Inspire Northeast Wisconsin, we have been joined by NWTC and UWGB to sponsor, and the Northeast Wisconsin Manufacturing Alliance to sponsor these virtual job spotlights. Today for our last manufacturing job spotlight, we have representatives from BPM and Fincantieri Marinette Marine and hopefully UWGB. So with us today is Dan Stubenville, the maintenance millwright at BPM, Ethan Snodgrass, an industrial engineer at BPM, and then from Fincantieri Marinette Marine, we have Brandon. Unmute. There we go. Someone muted me, so please don't mute me if you are one of my co-hosts. Kevin Stumbrus, the general foreman, and Alan Ford, the area manager, all in manufacturing over there. And then Dr. Patricia Terry, a professor of engineering technology at UWGB. So just a little preview, in November, we will be highlighting healthcare virtual job spotlights. So our first one on November 4th is a combination of, again, 4 speakers, senior care management and nursing are 2 of them, and then chiropractic and radiology. And most of you should have gotten that registration link sent to you this morning, along with the link to the slide deck. So just a little reminder of our meeting norms. The meeting is being recorded and broadcast through Inspire Northeast Wisconsin. Everyone is muted, so this prevents distractions. Everyone's video capabilities are turned off, so you will see the presenters as they are speaking. Only the presenters will be sharing the screens. Actually, I'll be sharing my screen and then going back and forth between viewing the presenters and sharing some of their slides. If you do need to leave the meeting, I'll keep an eye on anybody that needs to be left in, but there's not a guarantee once we get started. So if you decide to leave, you may not be able to get back in. Please ask questions of our presenters through the chat. Anything that is entered into the chat is visible to the group, and Allison from NWTC is going to be manning that chat and sharing your questions. And we don't anticipate needing to do this, but we do have the ability to remove folks from the meeting if they become distracting. So just a reminder that when we were looking at advanced manufacturing, we have a number of subcategories that we took a look at when we decided how to put together our manufacturing month virtual job spotlights. So today we are going to be concentrating on that electro-mech lane of the advanced manufacturing technology pathway. So I have a question for you, and I'm going to try a poll for the very first time on Zoom. So it should be on your screen right now once I launch the poll. So the questions are, what do you think is the minimum educational level to become a millwright? And what do you think is the minimum educational level to become a mechanical engineer? So you should be able to click on your answer, and it can be anywhere from a diploma certificate to an associate degree, a bachelor's degree, a master's degree, or a professional degree. So first for the millwright, what do you think is the minimum educational level required to become that? And then for a mechanical engineer, what do you think is the minimum requirement for an education to become that mechanical engineer? And it looks like millwright is between a diploma certificate and an associate degree. For the mechanical engineer, it is unanimous that it is a bachelor's degree that is required for that. So I'm going to end that poll, and we can see those results. So that was my first time using a poll in Zoom, and it went very well. So thank you for answering that. So we will be hearing about that today and finding out if your answers were correct. So first we will be hearing from Dan Stubenville, the maintenance millwright at BPM. So Dan.
Hi, good morning. I'm Dan Stubenville. I'm a maintenance millwright at BPM, like you had said. I guess I'm supposed to share my journey from high school until now. In high school, I had pretty good grades. My idea of my profession that I was going to be doing in the future was going to be some sort of a businessman, I guess. That just appealed to me. I was good at school, like numbers. Then I think it was my junior year, I had taken a career assessment test. I'd have to say about 90% of the career suggestions had to do with manufacturing. That was pretty shocking to me. That's not something I ever imagined I'd be doing. I didn't take that route right away. I went to college in Minnesota for about a semester. Then I came back to Marinette and took another year. Went to UW Marinette and went there for a year. And it just wasn't rewarding. I had no interest. I had no direction. I didn't know what I wanted to do. I knew I didn't want to be a businessman anymore. So I just jumped in and started working different jobs. Worked in restaurants, worked in retail, got a job at a warehouse, and then eventually I got married and I decided I should probably get a better paying job. So I got a job at a local manufacturer in Marinette. And when I went in there for my interview, I was just amazed by all the moving parts and everything. I didn't know anything really existed like that before. My dad was a minister, so I didn't get to see the like carpentry or working on cars or the factory aspect of people's lives like there are around here for so many people. So I went in there and I saw the robots and different machines turning and people moving around and making these parts. I was really impressed and I was actually happy to be there. For the next 2.5 years, I worked at that manufacturer and really dove in and tried to learn as much as I could because it was actually interesting. After that, there's a few layoffs throughout there and I worked as an operator. I worked my way up at another company to working in a lab, but it was always seemed to be a little monotonous for me. Some people enjoy the day-to-day work of going in, predictability of being an operator, things like that. But I wanted more. I gotten a job at another company as a setup person on their machines. That was more my speed or your troubleshooting and trying to make the perfect part the first time based on your knowledge and training. I got laid off from there and I said, you know what? I just went out and got some odd jobs. My wife had a decent job with insurance, so I was going to search for the dream job. I applied at a few places and BPM gave me a call and invited me in for an interview. And I got the job here. I really like it here. The job is really rewarding. Day to day, you don't know what you're walking into most of the time. I guess you do have our planned projects that we're working on, but anything could break overnight. Anything could break during the day. There could be new problems that arise. The problem solving part of being in maintenance or being a millwright is what I like because it keeps my mind busy. Not as monotonous as an operator, which operator jobs are good. It just wasn't my speed. What else I got here? So I graduated this past May from Millwright schooling. And I've worked here for a little over 4 years. So I don't know if I'm supposed to give an answer to the question that you had pulled. But it took.
Yeah, absolutely. So,
Okay.
so to get this job, I mean, you've kind of had a varied background, but if somebody just wanted to come in as a millwright, what recommendation would you have for how much education they should have before they apply? Or is that something you could do right out of high school?
It's something maybe you could do right out of high school, but I would recommend maybe getting a 2-year electrical mechanical degree from a technical school. That would give you a pretty good background, a little bit of an understanding of what you're getting into. But as for, and usually experience in the field, it helps out a lot before you jump in and be a mechanic. But I went to 4 years of school for the Millwright degree. That was like every other Monday. So it wasn't like I was going to school full time, but also coming to work. There are hourly requirements. We had to meet 8,000 hours of work, which is roughly 4 years of work where you're training on the job. And then every other Monday at NWTC for 8 hours. It's a full day. I think it's 576 hours. My engineer had asked me to take additional classes just to familiarize myself with the electrical part a little bit, and even some welding, just dive into welding a little more. So different companies might have different requirements and additional schooling that they would want you to have, but the minimum is 8,000 hours or 4 years of on-the-job training and 4 years of school.
Was that considered a registered apprenticeship, Dan?
Yes.
Got it.
Yeah, I was registered with the state of Wisconsin through their Bureau, I don't know, what is it called?
Maybe Department of Workforce Development.
Yeah, maybe Department of Workforce Development or the apprenticeship
So
board.
it's possible for a student to have a position like this and continue working on their education and have that paid for by the company, is what I'm hearing.
Yes, it is. They paid for my schooling. They paid my wages while I was in school.
All right. So do you have any advice for students about, you said that you didn't come from a background of manufacturing, so you really didn't know what it was about until you walked in the door, really to do your interview. So what recommendation might you have for a high school student who just kind of doesn't know what they want to do with themselves after they graduate?
I'd say get some experience. Factory is a really good job. That'd be a good place to get into, in my opinion. Maybe that's the step I should have taken, but I'm pretty happy with where my life is right now. It pays well. There's jobs that you can get in these manufacturers that are rewarding. A lot of companies will pay for schooling while you're working for them, but then they'll require you to remain at the job for a while afterwards. I know someone had gotten a nursing degree while they were working as a machine operator because there was a nursing position at a company I was at. They were willing to pay that person's nursing schooling. So there's a lot of different avenues. I mean, if you want to be an accountant, there's accountant jobs at most manufacturers. So company could pay for your accounting schooling while you're an operator. So there's a lot of different avenues, a lot of different benefits to working in at a manufacturer.
All right. So I'll have Allison check the chat and see if we have any questions. If you do have any questions, it would be great for you to put that into the chat. But what is the most fun part of your job, Dan?
Most fun part of my job is solving the puzzles, solving the problems that are around here to every day. Every day you come in, there's something different. I like the variety. I think that's the coolest and most rewarding part is you find a problem and you fix the problem. You solve the problem. There could be 10 different moving parts on a machine or a specific part of a machine, and you got to narrow it down a lot of the times to the one part that's failing and kind of finding your way through that maze or a blueprint. I like that challenge.
Great. Allison, do we have any other questions in the chat?
There are no other questions, no.
Okay. Well, we can then move on to just some pictures of millwrights at work. But we can move on to also at BPM, Ethan Snodgrass, who is a mechanical engineer at BPM. So he's going to tell us about his career pathway and then what he does at BPM on a day-to-day basis. So Ethan, go right ahead.
All right. So when I got out of school, out of high school, I went into college. when I went into college, I went at engineering school. I went to an internship every year that I was in school. My goal there was to try to get experience out in the real world and figure out what I wanted to do when I got out of school, because being out of school is different than being in school. So the first year I worked at an electronics factory, and that was a lot of desk work, and I didn't like sitting at a desk all the time. So the second year I got to work at a testing lab for the same company doing tests, which was better because I got to do more hands-on things. The third year I wanted to do even more, so I went and I worked at the power company, and I did an internship there where I learned how to test different power plants, and that was good hands-on experience. The fourth year that I was in school, my last year in school, I worked at a paper mill, planning projects and making processes work differently. So I used that time in school to figure out what I wanted to do when I got out of school. And then when I went out of school, I knew that I liked solving problems, because that's what engineers do. They find ways to make things better. They find ways to solve the problems that are out there. So when I got out of school, I then went and I worked with heavy metal fabbing, making and designing steel plates, figuring out how processes would work. And then after a few years of doing that, I wound up here at the paper mill, which is back to what I had been doing when I was in school, designing and developing projects at the paper mill. So that was my path. It looked a little bit different than what some other people did. Some people get out of school, they know exactly what they want to do, and they go and they do it right away. But I do think there's benefit in taking time to make sure you know what you want to do, as opposed to getting halfway into a career and then deciding that you don't actually like what you're doing every day. So I found it easier to take a bunch of little gradual steps by practicing every year with an internship, as opposed to just getting out of school and jumping right into my first job. So that was the first thing that first piece of advice that I would give to students, is to take the time to understand yourself and what you enjoy doing so that you can find the right match. Here at the mill today, on a daily basis, I'm plant engineer, so I'm responsible for making sure the plant is operational, making sure everything works. Every day I come in, I check, I make sure. This is a 24-hour plant, so there's stuff happening all night. So the first thing I do in the morning when I get here is I check and make sure that nothing broke last night, or find out what did break, what needs to be fixed, get a work list together for the day of what we need to do today. And then we'll spend the day maintaining or upgrading the machines as needed. Maybe a piece of machinery broke, maybe a new piece of equipment needs to be ordered. Today we're rearranging some pipes to make water. We're using some water showers in a way they weren't originally designed to do, so we have to figure out how to make them work differently, because our needs are different now than when the system was first put in. So we're playing with water hoses today. And tomorrow it'll be something else. Every day is a little bit different. If there is time left over at the end of the day, or if there's a large project going on, as you can see in the pictures there on the screen, I will also then have to work through designing and developing new machinery and getting that installed. So there's some pictures there of a piece of equipment we just put in. We're putting in another one here in a few more weeks, where I had to make sure that we're upgrading the paper unwinding system to handle a better way of picking up and handling paper rolls. So that's the sort of challenges that I deal with. Sometimes I walk in and I'm handed a piece. This is just a little piece of hollow metal that was handed to me, and I had to figure out what it was. And I didn't know what it was. It was just something that was found in the sewer at the plant, and to find out what was going on. So that required being a detective, kind of like Sherlock Holmes. I had to go and identify what the piece was. This ended up being a part of a steam cooker that had broken. It's a steam nozzle. But I had to figure out what that was, and that led us to a broken steam cooker, and we could replace that broken part. But we had to follow the clues to get there, because when I first was handed this piece, it wasn't clear what it was. It's just a piece of metal, but it has a story to it, and figuring out that story is part of what I do every day.
Well, that is a great story. I mean, who would think about the fact that, yeah, as part of my job, I follow clues. That is awesome.
Yeah.
Can you remind me, you talked about your going to school, but what you did get your degree in?
I'm a mechanical engineer.
Okay,
Sorry.
so that's the name of the degree?
So I have a bachelor's degree in mechanical engineering and a master's degree in engineering design.
Got it. So in answer to our question then at the beginning, what's the minimum amount of education needed for somebody who is interested in becoming a mechanical engineer?
Engineering is about problem solving. I'm going to give you the unconventional answer. if you can solve problems, that is more important to most companies than having a degree. I know people who have made engineering work without a degree, but it's more work. It's easier to get hired if you do have degrees. So I think it is a good idea to have a degree, but minimum, it is possible to be an engineer with no degree at all. The question is, can you apply the mindset of problem solving to the problems in front of you? That's what makes or breaks an engineering career.
Got it. And I'm going to go back a couple of slides because we saw some really fun things on the screen, but didn't know what they were about. So tell us a little bit about what BPM all makes.
All right, so cough drops. You guys see that all the time? We make paper for wrapping food. So candies, cough drops, suckers, wax paper, sandwiches, that sort of thing. Hamburger patties that you buy at the store that have sheets of paper between them, cheese interleave, that sort of thing is the paper that we make. We make and we print it and we wax it here in Peshtigo, and then we ship it out to the candy companies to be wrapped around the actual food. We also make some printing and writing paper. That's what the center of the screen is showing. This is the stuff you put in your computer printer, or sometimes we'll make large, we have a line of large calendars and poster paper that we sell to print shops that they use to make large flyers, or the things you get in the mail, or posters up on the wall. So there's a broad range. We have a bunch of different customers. We don't make just one thing. We have a bunch of different niches, which is useful. This summer, there was a drop in candy consumption, but there was a rise in cough drops, so we still kept the plant busy. As opposed to if we'd just been in candy, we might have been working shorter hours this summer than we were. So it's good to have a bunch of different things that we do.
Mm-hmm. Oh, I love that. Yeah, all the dum-dum sucker wrappers are made there. So that's
There
all
are
what
some
I remember.
Some niches we have cornered. We make all the dum-dums, but for cough drops, we make most of the ones in the store, but we don't make all of them. We make just some of them.
Mm-hmm. So you gave some great advice already. I'm hoping that if students have any questions, they will put those into the chat. But yeah, I love your idea of getting out there and getting experience in a lot of different areas so that you have an idea of what you really want to do once you get done with that degree. So do you have any other advice for our students?
Focus on the problem solving. That's what you're trying to learn when you're going through engineering school. A lot of people get distracted by, if you look at the curriculum for an engineering school, it's typically a lot of math and a lot of science, and those things are not themselves the end goal of an engineering program. They're trying to give you really, really hard math, not because hard math is what you need in the field, because it teaches you how to solve hard problems. So every engineer every engineering program I'm familiar with requires a bunch of advanced calculus and math, but very few engineers actually need that. The goal is to learn the approach to a difficult problem. Because when I'm handed a piece like this, it's not clear what the answer is. There may not be an answer. There isn't a book on how to run a paper mill, and certainly not our exact paper mill, because our mill is different than other mills. So we kind of have to write the book as we go. There isn't one answer predefined already. So that's why the programs are so hard. But don't get lost in that. Just keep focusing on the problem solving, because that's what you're trying to get out of the schooling.
Excellent. Allison, anything in the chat?
There is nothing in the chat.
We do not have
That's a
chat.
bummer. So best and worst, the best part of my job is that, as Dan said, we have new challenges every day. I don't often do the same thing twice. It's almost always a new thing every day. And that leads to a variety. It keeps me from getting bored, because I have the personality that would get bored if I was doing that every day. And the worst, generally in engineering for my job, is that there's some problems are not able to be solved. If I wanted to take Jell-O and make a toothpick, I could try really hard and I could do a lot of thinking. I could read a lot of books. And at the end of the day, I'm not sure Jell-O will ever make a good toothpick. Or if it does, you should probably start making them, because I've never heard of it working. So sometimes you have a problem that is not easy to solve, and you look at it and you think at it and you try and you just can't get to the right answer. And sometimes you have to go and pick a different answer and say, maybe I can make a toothpick out of a piece of wood and it would work better than if I tried to use Jell-O. And that's sometimes frustrating that I can't get to the answer that I want to get to, but that is part of what makes the discovery exciting, is finding the way that does find the work at the end of the day.
Excellent. Well, thank you so much for sharing your time with us. And we are going to move on to three gentlemen from Fincantieri Marinette Marine. We have Brandon Haas, the foreman, Kevin, and I have to move my screen over here just a tad, Stumbrus, the general foreman, and Alan for the area manager. So they're going to be telling us a little bit about what they do at Fincantieri Marinette Marine. So gentlemen, whoever would like to start.
I'll start. Hi, everyone. My name is Brandon, or Brandon Haas. I came here straight out of school, been at Marinette Marine for 18 years. I had no education after high school. This job just kind of fell in my lap, so I ran with it. It paid well, and it's been fun for me from the beginning. I started here as a pipe fitter, and I did that for a few years, and I took everything I learned and turned it into something better, in my opinion, which landed me on the waterfront at Marinette Marine on the test and trials crew. So I did a lot of testing of shipboard systems and equipment, including damage control, which would be fire main, and we also use AFFF, which is made here locally in Marinette also at our neighbor Ansel. And after 10 years or so of being on the test and trials team, I decided to jump over to the management side to try and take my skills and apply them or share them with the rest of the team. We bring new people in all the time, and they remind me of myself. I came here, like I said, right out of high school. So I see a lot of new people coming in, and they're green. Not a lot of knowledge, which again was like myself. I didn't know hardly anything when I came here. And this has been, to say the least, a blessing. It's close to home. It's allowed me to raise my family very comfortably. It's been an excellent place to work. And my favorite part is dealing with hundreds of people a day. You have so many different personalities. It's very fun. A lot of laughs. It's kind of laid back, but it can be very stressful. We are selling a huge product to our military currently. And so now, as management, I am a test supervisor. So with that being said, that I take test procedures from every trade, including electrical, outfitting. We have a machinery department that handles the big machinery, main engines, big equipment. And I take all of that. We make sure that we're following the build spec, which is provided by our government, and a lot of relationships with government people also. And those relationships are irreplaceable. So like I said, I've had a lot of fun in this job. I really appreciate it. And it's taught me a lot. I consider myself to be very mechanical at this point, and I hope to be an engineer someday. You know, as the previous gentleman was saying, he doesn't believe you need post high school education to be an engineer. You need the experience and the ability to troubleshoot, and that's what I've done for a lot of years, and I'm hoping to apply that to an engineering job soon.
Awesome. So you did mention, Brandon, that you didn't have any education after high school, but I'm imagining when you went into the management track that you did have some education you had to do. Would that be correct?
No, high school wasn't great for me. You know, there was classes. There was a few classes I liked, including a drafting and design class. That was one of my favorites. I was very good at math and science, so I mean, I imagine I always wanted to be an engineer. So when I came out of high school and this job kind of hit me in the lap, I thought no better time than now to make some money. And I never pursued after high school education, and I'm still here.
Awesome. All right. Who do we have next?
My name's Kevin Stumbrus. I've been here at Marinette Marine now for 13 years. I came out of high school. I worked for a family business in the plumbing industry. And I started an apprenticeship with them. And over the years, I worked on multiple projects, hospitals, jails, schools, stuff like that. And then I just decided that I was traveling around the state. And then I just decided one day to stay home more. So I applied here at Marinette Marine, and I came here. I was a pipe fitter for 5 years, and I took a foreman position. And then I moved up to a general foreman. And I like to work. It's something different every day. Every day you come in here, you're doing something different. Even if you're just a pipe fitter, it's always changing. You're never doing the same stuff. You don't get bored or nothing.
So did
That's
you
about-
have any particular high school class that you thought, or classes that you took that you thought were really helpful in the skills that you needed for what you're doing now?
Well, your math class, science classes, stuff like that. You need to know your math for you. You do a lot of math in pipe fitting. You know, it's not hard. It's just formulas. You figure it out, and then you just got it. You know what it is.
All right, great. Well, I know we have a question, but I think I'm going to wait for that question until we've heard from all three of you. So next.
Yes, I'm Alan Four. I'm the pipe area manager here at Marinette Marine. I've been in the shipbuilding business for about 30 years now. I've worked at 3 shipyards. It's a great family business, and I say it's a family business because of the people you meet, the people you work with each day. I've built ships for the Navy. I've built ships for the oil companies. I've built ships for the Coast Guard. One of the advantages of working in the Navy and for the Navy is you see something come to life. Here at the company, we start with just a sheet of steel, and it's awesome to see that sheet of steel turn into a ship and go right out into the sea, to know that it's a home for some of your brothers, some of your sisters, your parents. It's a great feat to know what we're doing and how we're helping. We help the Navy, we help the country with safety, we help the country taking care of each one of us daily. Key courses that I went through in high school, drafting was great. Math is real good. Science is great. Much like your Millwright, when you're in math and you're in your science and you come out here and you apply it to building ships, it's a key to problem solving. What degree do I need? How is this pipe going to go together? What is going through the pipe? Are we going to send water through the pipe for someone to take a shower? Are we going to send cold water through the pipe so you have air condition on the ship? Are we going to send air through the pipe so somebody can fix a flat tire? So it's all great things to know and great things to learn as we progress.
So what are some of the things that you do on a daily basis, Alan?
I try to reach out and touch each and every foreman that works for me to problem solve for them. How is your manning today? Did everyone come in? Is there something that you need from our purchasing department that they didn't buy? Is there something you need from our planning department that I need to get out of the warehouse for you? Where do you stand with engineering? Did they give you a good drawing product? You talk about the Navy and Lockheed Martin. I look at myself as the cream filling in an Oreo cookie. I'm kind of the middleman, right? My guy tells me I need something. I need to go to the Navy and say, hey guys, we need to work together. What do we have to do to resolve this? What needs to happen in order to make it successful for everyone?
I love that analogy. And I know we have a question, Allison.
We do. All right, gentlemen, what are the challenges in working with the government? And does the process to build take longer?
The process definitely takes longer. We are very big on quality at Marinette Marine. There's a lot of proud people that work here. We want to deliver the best product we can. We take it personal. I know I definitely do, and I see it throughout the yard. I love working for the Navy. I think them guys are great. Like I said, to meet these people, to build friendships and these relationships with people from all over the country. It's just been awesome. They will challenge you on a day-to-day basis to make sure, almost to try to keep you in check. And it's kind of fun. It can kind of be a game, and you'll see them smile and snicker while they're trying to make your life harder. But you take them challenges and you run with them, and you make them the best you can.
All right. Yeah, I'm hearing a lot of themes of problem solving in really all of your positions at both companies. So thank you so much for sharing. And we are going to, let me jump back to share screen.
So I'm Professor Patricia Terry. I'm the chair of the Rush School of Engineering at UW Green Bay. And we have majors in electrical, mechanical, and environmental engineering technology. Aha, here we go. Thank you. Okay, so you may have to control this for me too.
I will do that. You just tell me when you need to go to the next slide.
Yeah, we can go to the next one. Yeah, right. So we have degrees in computer science, electrical, environmental, mechanical engineering, technology, and mechanical engineering and mathematics. And in fall of 2021, we are going to launch a bachelor's in electrical engineering. So I'll just go quickly through each of our degree areas. So we can start with computer science. All right. So computer science is a field for students who are interested in technology, programming, and problem solving. We have particular emphases in cybersecurity and in software engineering. All right. So different careers with students that have a bachelor's degree in computer science. Northeast Wisconsin has a high demand for this particular degree area, especially because cybersecurity is such an important topic these days across all of industry and manufacturing. So students can have careers as computer analysts, as web designers, as software designers, and as network managers. If students come to UW Green Bay, they'll have opportunities for paid internships that will help them pay for their college degree. And of course, they can always pursue graduate degrees. We have an online master's in cybersecurity here at UW Green Bay. Okay. Right.
Nope. I've got one page that didn't load.
Okay. All right. So in mechanical engineering, and you've already heard from some people working in the field as mechanical engineers. So mechanical engineers apply physics, math, material science, and fundamental engineering to solve industrial problems. So they design, analyze, manufacture mechanical systems. Again, we offer this bachelor's degree at UW Green Bay. Students who come here will have opportunities for paid internships that have led to future employment, or you can pursue a graduate degree in mechanical engineering if you want to go to work in research and development. We can go on. All right, so for the engineering and engineering technology degrees, students work across a vast spectrum of industry. Places that you would expect, like auto manufacturing, the aerospace industry, electronics design for electrical engineers, computer technology. for the computer science faculty, but also in areas you would not anticipate. Right now, almost all industry across the United States has been automated, and those that aren't are rapidly moving that direction. And with the automation of industry, you need computer scientists who know how to program. You need electrical engineers who understand the machine-computer interface for controlling the automation. And of course, you need mechanical engineers for designing the equipment. So because of that, we find all of these people working in food processing industries, in paper manufacturing, in waste treatment, pretty much across the entire swath of industry. Environmental engineers, of course, can go to work as environmental consultants, and also across the entire swath of industry, because all industries are required by the state and federal agencies to meet certain environmental regulations for air quality and water quality. So everybody across industry hires environmental engineers. All right. All right. So we have 2 degrees in mathematics, the more traditional mathematics route that you would think of, and a statistics route. But mathematicians do a lot more than we think of. So they apply fundamental principles to analyzing and solving real world problems. Mathematics, as you've heard from the other speakers before me, are required in industrial and management positions, and even in social positions.
Problems.
I wonder why some of my pages aren't loading.
Yeah.
Well,
So,
all right. Well, if they won't load, I can just talk about them.
okay.
So, people with degrees in mathematics go to work across a vast spectrum, especially the people with the statistics background. The insurance industry, investment analyst, all of these different types of industries hire people with expertise in statistics. People with math and statistics degrees can go to work as data analysts, as game designers, along with computer science, as economists, as controllers, as accountants, and as encryption specialists, again, working in conjunction with computer science faculty. So lots of career opportunities out there in these various STEM areas. So we can go to the next one. So I always tell prospective students, and hopefully some of you guys will consider UW Green Bay. Why should you consider us? I'll say first off that we have smaller class sizes for math, computer science, and engineering. We don't have giant lecture halls on campus, at least not very many, so we can't pack them in, 500 students to a lecture hall, which is how I took freshman chemistry at the University of Texas many years ago. Because of that, our faculty are very teaching focused. People who come to UW Green Bay as faculty members come because we enjoy teaching. And you're not going to get that at a lot of the bigger, what we call Research 1 or R1 universities, where the primary focus of the faculty is working with graduate students on state-of-the-art research. We still do research here. It's just that we also find teaching to be very, very rewarding. We do not have graduate programs here in engineering. In computer science, we have the cybersecurity, but that's the only one, or mathematics, which means there are opportunities here for undergraduates to be involved in research that you wouldn't get at a bigger university that has a graduate program. So a number of our faculty have done research with undergraduate students and have gone on to present and publish this research at technical conferences. We have state-of-the-art facilities here. So a year ago, we launched the opening of a new STEM building on campus. It has 5 labs specific to mechanical engineering technology, in addition to a computer lab that has CAD, SolidWorks, and lots of other type of software packages that engineers do. So all of our equipment is state of the art. We just got a big grant from the UW system to upgrade our electronics labs to launch the new electrical engineering program. So by the time students get here, well, we're going to start the remodel. So probably it's going to be until January of 2022 that we're ready to fully launch the new facilities. But students would get through a freshman curriculum before they would get there anyway. So by the time you would come to UW Green Bay, we would have state-of-the-art electronics facilities. We have a crazy number of scholarships that have to go to engineering or engineering technology students. So much so that we used to have a shared committee with the rest of the sciences, and they broke us off so that they wouldn't have to worry about figuring out who was going to get our scholarships. But last year we gave away over 25 scholarships to engineering and engineering technology students. The highest one was $5,000. So that'll go a long way towards paying for your education. The other really big plus about UW Green Bay is internships. So this area, the city of Green Bay, up to Marinette, where you have Fincantieri, and up to Sheboygan with the other shipbuilding industries, and all the way down to Fond du Lac. This area is the industrial base of the state of Wisconsin. So because of this, our students have a very easy time getting internships, and most of those lead to employment after they graduate. And the nice thing is, since the company you're interning with is probably located in town, you can work part-time during the semester while you're going to school and get practical experience and pay for your education. So with that, I'll just leave and see if anyone has any questions for me about our programs.
So I see there's some in the chat, Allison.
There is not specific to this.
Okay.
Yep.
So, and I know.
I was just curious how many students you have right now in the various, on your side of campus.
On my side, well, I know that for mechanical engineering, we have about 130 declared majors, which, given that we launched the program in fall of 2018, fall of 2018, we're about double what we thought we would have. We were our highest projections for this time. So, you know, we're having to offer multiple sections of classes already to accommodate students. That's a problem that we love having. Between the three, I think we've got about 50 majors each in mechanical and electrical engineering technology. And I think we've got about 30 majors in environmental engineering technology. So we're a rapidly growing program. The same for computer science. It's been around for a while, but we recently had some key retirements of older people, and we hired some new people into the area that are really revitalizing that degree. And with the addition of cybersecurity, we're seeing a lot of growth there.
All right. Any other questions?
Yeah.
Hearing none. Thank you so much for that information, Professor Terry. And we do have the evaluation survey link up on the slide. So if you did not get it sent this morning along with the link, we would love to hear from you with the job spotlights that we have coming up. So please complete the survey. And I want to thank all of our speakers today in the electromech engineering world, and all of the speakers that we've had during Manufacturing Month. It's been very enlightening. So thank you very much and have a great day.
Thank you.